Wildcards provide us one way in which we can use the shell to perform actions on many different files at the same time. But there are some situations where we can't do everything we want to do with wildcards, so we're now going to talk about another way that you can perform these sort of automated, repeated actions on many different files or many different sets of inputs using the shell. And again, this is another way where the shell really distinguishes itself in terms of its capabilities and the way you can perform large analyses very easily. So to look at using loops, which are the shell feature we're going to take a look at now, we are going to work in a slightly different directory. So you should still be in the molecules directory where we left off before. For this section of the course, we are going to cd up one level and then back down again into the creatures directory. Let's take a little look at what we have here. We have only 3 files corresponding to fictional creatures, and let's take a quick look at the contents of those files using the head command. So let's use head-n5 just to get the first few lines of each, and then we can use a wildcard as we did before with the .dat suffix. In fact, as there are no other files in this directory, we could just use the asterisk by itself, but let's use the asterisk.dat for clarity. Execute that, and we see the first 5 lines from each of the files. Head is even nice enough to give us a little thing at the top of each one that tells us which file each bit comes from. So there's this common format for the files you can see, where we have the name of each creature, its classification, some details on when this file was updated, and then what looks a lot like some genetic information beneath that. So let's say that we wanted to get the classification of each of these creatures. So we could use the head command here, -n2, to get the first 2 lines. And let's work with just one file for now. Let's just work with basilisk.dat. So this will give us the first 2 lines of basilisk.dat, and then just to get the classification line, we can pipe this into head's opposite, which is the tail command. As you might expect, this gives us the requested number of last lines of a file. And if we then provide a -n1 here, we are just going to ask for the last line of the input to tail, which is just going to be the second line of basilisk.dat. If we execute that, then indeed we see we end up with just the one line, which is the one that we want. So one way in which, so let's imagine now we want to scale this up and we want to get the classification of for all of the creatures in the current directory. So what happens if we try to use a wildcard for that? If we again press the up arrow to recall the last command that we ran, and then we can scroll back using the left arrow back into our command, and let's change basilisk.dat to just asterisk.dat. Now, in principle, it seems like we will maybe get the classification of all the creatures that we want. But let's see what we get. We only get the last line. So the reason for this is that when we run head with the wildcard, all of the output, all of the files get combined together into the standard output of head, and then tail only reports the last line of all of the input that it gets from all of the files, so it only reports the last line of unicorn.dat rather than working on each of the files individually. Tail doesn't know anything about the fact that head was asked to work on multiple files. Tail only sees the output that came from the head command, and that all came in one go. So wildcards can't quite do what we want to do here. Instead, we're going to use a different construct called a loop. So I'll start with just writing out the sort of loop in full, and then I'll sort of circle back on explaining how it works later on. So it starts with the keyword for. So this particular, there are multiple types of loop. This particular type of loop is called a for loop because of the for keyword that's used here. Then we specify what's called the loop variable. We have a free choice here. I'm going to pick file name, and we'll explain a little bit about why later on. And then we can say for file name, then this is followed by another keyword in. Then you provide the list of items that you would like to iterate over with your for loop. So in this case, I'm going to provide all of the file names that we want to get the classification lines from. Hit return now. Now notice that our prompt has changed. So rather than getting the full prompt that we had before, we're just getting a single character. That's because we've started to write a loop, but we haven't actually finished it yet. The shell recognizes that there's still some stuff to come in our loop, and so it uses this special character to signify that it's expecting more input in the specification of the loop. After the first line, we can then follow that up. Well, we then have to follow that up with another keyword, which is do. That's a line all by itself. I'm now going to put in a couple of spaces here. These aren't actually required, but for visual clarity, it's considered a good idea to indent what's called the body of the loop, the commands that are actually going to be executed when the loop runs. And this is just to make your code easier to read, and it's a universally sort of applied kind of formatting rule. So now we want to include the command that we actually want to run, head-n2. Then rather than providing any of the individual file names, I'm going to use $file name here. Then again, we will pipe that into tail, -n1, hit return. One last bit of syntax is required, which is the done keyword. Done signifies the end of the loop, and when we hit return now, the loop will execute. Okay, so now you see that we've gotten the three classification lines that we wanted, one from each of the files that we were interested in. So, to explain a little bit about how the loop works, where we specified file name here, as I mentioned, this is known as the loop variable. Essentially, the command that we've indented here is known as the body of the loop. This is executed one time for each of the items that is provided after the in keyword. So we've provided the three items, basilisk.dat, minotaur.dat, and unicorn.dat. So the contents of our loop is going to be executed 3 times. Each time this is executed, the value of the loop variable, denoted by this $sign, which is used to denote variables in the shell, each time that the loop executes, $file name will take on in turn each of the values specified here. So the first time the loop executes, $file name will have the value of basilisk.dat. The second time it executes, it will have the value of minotaur.dat, and so on. As I mentioned before, we do have free choice in what we use as the name for our loop variable. For instance, it's perfectly valid to say for x in basilisk.dat, minotaur.dat, and unicorn.dat, do, then indent the body of the loop again with a few spaces, head-n2 $x. Pipe that into tail-n1 again, and finish the loop with the done keyword. So once again, we get the 3 lines that we're expecting. This loop works in exactly the same way. It gives exactly the same output. All that's changed is the name that we've used for the loop variable. It is much better, if at all possible, to use a descriptive name like file name for your loop variable than it is to use a variable, the name just like x. Just because having a file name here is much more legible, and it communicates to anybody reading the code the idea that the contents of this loop is going to be over what are file names that will be then used by the body of the loop. We could even choose something terribly misleading, but for the same reason as that we want to choose a properly descriptive file name, choosing something misleading is a very bad idea indeed. So in order to get the full power out of this loop, we can actually combine it with a wildcard. So what we can do here is we repeat the first form of the loop that we provided, let's say for file name, in, and then we provide the wildcard *.dat. The do keyword is next, a few lines of indentation, and then head-n2 $file name, pipe that into tail-n1 with the done keyword to finish. Hit return and that executes just fine. So, as mentioned before, wildcard expansion is the first thing that the shell does when it goes to execute your command. So, this works inside the loop as well. So, star.dat is simply being expanded to the value of these 3 files, and this loop is then completely equivalent to the loop above it, except that if we add more files ending with .dat in the current directory, then the loop will automatically incorporate those as well.